All right, so let's try 11.3, number 43, which has this giant paragraph about a box. Okay, so I want to pack a cardboard box inside of a wooden crate. So here's my wooden crate.
Oh, that's actually a decent picture, though. I'm impressed.
It's actually not that good. Okay, so, alright, so there's my wooden crate, which is really crummy. And then they tell me that I need a cardboard box in this wooden crate. And it needs packing materials, which means I need to leave a ½ a foot space around the front, back, and sides.
It's a lot of cushion.
Yeah, that's a ton of cushion. Okay, so this gap here, right, is 6 inches. And then I'm supposed to leave a 1 foot space around the top and bottom. Okay, so I need to go up a foot, right, to get my corners. And then I need to do a similar thing here. So I need to go down a foot from the top. Okay, I'm wasting a lot of time drawing this.
Looks good.
Okay, so I have my blue cardboard box inside my black wooden crate. And I know that I've got a foot top and bottom gap, and then all around the outside 6 inches.
How did you come up with the 6 inches?
They said it was a ½ a foot.
Oh,
Maybe I should make everything feet. That's probably a good idea. Okay, so it's 0.5 feet. All right, now they want to tell me if the cardboard box is X feet long, and these are not going to be to scale because I just drew this at random, X feet long, X plus 2 feet wide, and X minus 1 feet deep, whatever the heck that means. So label the other side, right? Find a formula in terms of X for the amount of packing material needed.
The amount of packing material needed?
Yeah, so I need the amount of packing material needed.
So we're not even finding the volume of the box inside
Well,
the
you need the
crate.
volume of the blue box inside minus from the volume of the big box.
Okay, so I think packing material, right, is going to be the black volume, right?
Yeah.
Subtract, what were you saying?
The volume of the blue box.
Right? The amount of packing material should be the black volume minus the blue volume. Get a blue volume should be dead easy. What's the blue volume?
X minus 1 times X times X plus 2.
X minus 1 times X plus 2. Boss. Very nice. You guys all see that? Okay. Now, how big is the black one?
X plus 12 and X
Whoa.
plus
No.
2 plus 12?
No. Too big. Where'd you get a 12?
Oh, sorry, inches. So plus a foot?
Okay, so let me look at the height here, right?
X plus 1 plus 1
So that's
Oh,
x.
you're doing inches.
X minus 1 plus 2.
So it's x minus 1, right? That's the blue height. Plus 1 for the top, plus 1 for the bottom is plus 2. You guys with me on that?
I'm still working in inches.
That's the height.
No, the heights are, yeah.
The heights are 1 foot gap, 1 foot.
But the sides going in.
But
are
the
6
sides are only, yeah. So how about this one across the front here? It's x in the blue, right?
X plus 1.
And then a half on that side and a half on this side makes x plus 1. And then the other one is
X plus 2 plus 1, so plus 3.
x plus 2 plus 1. Cool. So I got x plus 1, right? That's the height, times another x plus 1, so square that, times an x plus 3.
Where did the plus 2 go?
Where does the
Two, plus two.
minus 1 plus 2 is plus 1?
Oh, okay.
So this bit is x plus 1, really. So I've got an x plus 1 times an x plus 1 times an x plus 3.
Alright.
And then don't simplify that. P of x is x plus 1 squared times x plus 3 minus x times x minus 1 times x plus 2. To do anything with that, you'll have to simplify it. But unless they ask you to, don't. Cool? Questions, Steele?
That's the whole problem.
Yeah, find the volume of the packing material.
It seemed like.
There's another horrible way to find the volume of the packing material. So the horrible way would be to calculate all the little bits and bobs. Right? So like here there's a little rectangle. You guys see that one? Like out at the corner there's a rectangle.
6 by 6.
And then it's 6 by 6 by 1.
So do it in segments.
And then
go all
there's
the way around
8 of
the
those.
Jesus.
And then you could figure out this one here across the front, right? Like that's 6 inches wide, a foot tall, and x long. And then there's, let's see, 1, 2, 3, 4 of those. And then there's 4 of the other one on the other side. And then there's a whole mess of in there, but under the box, and then in there, but above the box. Don't frickin' do that. No. That's like really annoying.
You got like your area above the box.
Yeah, so you could do, if you wanted to do a similar but slightly different problem where you stuck a cardboard box into an ellipse or something, into an egg, and then what's the smallest egg you can use? Yeah, that's a Calc 3 problem, and a horrible one at that. So yeah, it is possible to make horrible problems that sound like this one. When in doubt, if you find that you're splitting something into like
Segments.
lots of segments, like more than 10 or 12,
Don't do
either you're doing an engineering problem or you're doing it wrong.